I haven't seen this before.
Who of us hasn't left the TV on even though we're not watching? Who hasn't left the lights on even though we're not in the room?
My fucking wife. Yeah.
Nowadays, electric power is regarded as a common commodity. Just as the sun rises every day, we believe that electricity appears to be a straightforward issue. You press a button and you have instant electricity. It's as if it's hidden in the socket. But is this really how it is? Just one look out of the window reminds us that electric power comes from someone. It travels along the cables and the pylons of the Hellenic Public Power Corporation. If we follow these cables, we might be able to discover where it comes from. In Greece, the largest amount of electrical power is generated in Western Macedonia. 6 in 10 houses get their electricity from electric power stations in this area. Western Macedonia is the heart of the electrical energy in our country. Let's look then at how electrical energy that we take for granted is generated. In Western Macedonia, there is a large quantity of coal known as lignite. With the use of large machines, it is mined from the ground. Some of the machines are taller than an 18-story building and weigh more than 5,000 tons. After lignite is mined, it is taken to the electricity generating power plants on conveyor belts. In all of the Western Macedonia, there are 270 kilometers of conveyor belts. This is 1.5 times the distance from Florina to Thessaloniki. When the lignite arrives at the station, the process of energy production begins. First, it goes into a furnace burner where it is burned. From the combustion, smoke is produced, which escapes to the stacks of the power station. The burner generates heat, which heats up a large water tank known as the boiler. The water that is heated in the boiler becomes steam. The high pressure steam goes into a turbine. The turbine has large bladed rotors, just like the sails of a windmill, which, pushed by the steam, rotate at a high speed. In turn, these bladed rotors activate a magnet that generates the electric current. This magnet is part of a device known as an electric generator. Lastly, the steam is separated. Some of the steam is distributed to the surrounding cities and villages by a network of pipes to provide heating. This process is known as district heating. The remaining steam cools, condenses into water, and goes back to the boiler for reheating. Steam is used for chilling by spraying the pipes which convey it with water. The water evaporates and is released into the atmosphere through those characteristically large, thick cooling towers that appear to be forming clouds in the sky. Combustion, steam, turbine, electrical generators, electricity. Once electricity is generated in the power plant, it is distributed all over Greece to cables, which are found on the transmission line towers. It is through these that it arrives in our country. Highly trained personnel are involved at every stage of the process of generating electrical power. When at some point a conveyor belt tears, the welders are called in. They join additional pieces onto the conveyor belt to make it operate again. When a machine breaks down, the electrician fixes it. Thanks to them, the machines in the plant operate like clockwork. The rope access technician's work is very difficult. They climb the electric power pylons to fix them. They change the destroyed cables and join the couplings. They undergo special training in order to climb the pylon safely. Apart from all the highly trained personnel, there are also the machine operators, the excavator drivers, and the technicians. All of those people work hard so that the power plant operates non-stop the whole day. We saw that in order to have electrical power in our homes,
Yes,
it's
sir.
hard work. will be started by both people in the case. However, the generation of electricity also affects the environment. When lignite is mined from the ground, the natural landscape is destroyed. But 2 years from now, we will run out of lignite. We have already started using other resources of energy, such as the sun, water, and wind. Definitely, the sun will be around for many years, rising daily without our help. In contrast, electric power generation, as we have seen, is a most demanding process. Each time we press a button, let's not forget the long journey made by electric power to our home.
So that sort of halfway answered the
Not
question.
really.
I guess maybe if you look for wasted electricity, I don't know, keywords.
You know, it's not the electricity that's wasted. You create steam,
Yeah,
and that steam is wasted because you create a certain amount of steam. Now, the guys who operate the control panels are looking at the demand. They
Yeah.
can see how much current is flowing out to the city. As people turn things on and off, they see the current change. So they're going to adjust the amount of steam they're creating to try to maintain a balance. They don't want the generator running full steam all the time because they're creating more electricity than there's a need for. So the electricity isn't used, but the steam is still going to turn the turbines and evacuate.
so it's how much they're actually burning then. So that's what they're trying to control is how much they're burning because the less coal they burn, the less energy they get output. So it's all about the coal consumption,
Yeah.
correct?
Now, when I go to the Colorado River boating, I can't ski first thing in the morning because that water is used for hydroelectric power. So at night, when people sleep, they turn their air conditioning off, they turn open windows, all the businesses turn their lights out, their machines off. So during the night, the demand for electricity drops. So instead of letting all the water flow through the turbines, they restrict the flow. They shut down, there's like 20 generators, turbines, they'll shut several of them down and run just a few to maintain the output.
Raising the water level back up.
Well, to save the water behind the dam.
Right.
And as the demand increases during the day, so people start waking up, turning stuff on, now they start releasing more water to spin up more turbines.
Right.
They have,
Yeah, I can't do that.
Which permits the water to flow in the turbine from the feeder fence pump. Weighing 2,000 tons, N8 parts were shipped to Hoover Dam. Beautiful in the desert sunlight, already distributed downstream wells. Hot water is backed up with arch back as the reservoir fills. This man-made industry spread through valleys and canyons among the colorful hills and mountains. Hoover Dam and power Colorado. Turbine fits on manufacture and installation. Plants throughout the nation. Fabricated N8 for many parts. The design of N8 follows that of other Hoover generating units. As a 95,000 kilowatt being returned to the federal treasury.
now there's the turbines in Hoover Dam. That's not even all of them.
So
There's
that's the
one,
water flows
two,
through those
three,
turbines
four,
right there?
five, there's, I think there's about, let's see, 1, 2, 3, 4, 5, 6, 7. There's 8 here, and so they'll spin up all of them during high demand, and during night they'll shut some of them completely off.
In those turbines, is electricity being produced in those
Yes.
generators?
Yeah.
So where's the? I mean, I'm getting ahead of myself. But I'm just trying to. The water flows underneath it or through the
It
turbine,
actually flows below it.
below it, and then it pushes. So you got the turbine full of wires then, and then you got the magnet in the middle. Then I imagine.
Yeah,
Right?
so this is the motor part, and the water flows below. There's a shaft to it.
So it's like almost like a what do you call it? Upside down.
It's a propeller,
Oh yeah. Going up.
but they call it that might be the water part.
So the water flows and
Yeah.
it turns.
See, it's more like a
Gotcha.
bathroom fan. Those
Yeah.
cylinder
It just,
type.
you know what it looks like? It looks like one of those old-fashioned water wheels upside
Yeah.
down on the side, right?
Water wheel.
1961. Serve the state of Nevada.
And then is that the magnet right there? No,
That's the shaft.
that's the shaft.
I don't know if they have a good cross section of it.
The world's largest hydroelectric installation. As the last clouds of construction faded in history,
So with all that amperage, or I should say,
Amps current.
all that amperage going through, they must have some pretty big resistance. The transformers, is that what you call them? There's a,
You know they.
because you got a lot, you must have some huge wires. Am I right or wrong for that?
Yeah, it's like a
current?
big motor.
Like a
You've
big-
seen the windings in a motor, and it's
Right.
going to be spinning magnets inside
Right.
the coil wire.
And I suppose you have all those
destroyed man and his property.
wires going somewhere.
Serve
You know, ironically, I heard that the cleanest form of energy is out in outer space.
The purest form.
Yeah, the cleanest form, yeah, is out in space. I don't know why.
I know they've just strung wire out in space and generated electricity. Just an open wire. I've heard that the wire's just cooked. I don't know. It's not anything really I understand.
I wonder if that's got to do with the radiation. Because they're always protecting themselves and everything they have up there from radiation. Because it cooks everything. Okay, so that's what it produces and then.
So the water flows down below the coils of the turbine. The magnets and the coil are up here, and the shaft goes through a seal, so the water stays below.
I'd be curious to see how they. I mean, other than slowing down the turbine.
They don't slow them down because they have to run at a certain speed.
Oh, okay.
Because AC has what's called cycles. That push-pull
Yeah.
is, I can't
Alternating
remember.
current.
Who remembers what cycles are? I know it's 400 cycles in an airplane.
Yeah, 400.
Hertz. Is it hertz?
I think that's the same term. But it's different at home.
And that's per second, right? 400 per second.
Yeah, it's the cycles, the waves, where it pushes and pulls. And so that turbine has to spin at a constant speed. So what they're doing is when they start to meet the limits of the generators and they need more, they spin another one up. Once it gets up to speed, then they close a breaker and start flowing power current from it. There's probably endless pictures of this, the same area.
I was reading something about how the Nile, Egypt is having problems with their crops because they depend on the Nile. Because the countries south of them are starting to build these generators, which is cutting the water off to the Nile, up the end to there.
Probably what's happening, and that may only be temporary, because they have to build a dam. once they've got the dam, oh, you're right, because they're going to restrict the flow just to keep the water level high
Yeah.
behind the dam.
And
They're
even
still
when-
going to get water because they have to turn the turbines.
yeah, but because Egypt's at the end of the river, they're the ones that are affected the greatest.
Well, if the dam is full, then they have to release. They'll have to continue to release it to keep from breaching the dam. But there has to be water flowing in too.
So,
So if you've met the top level of your dam, you have to at least let out what is coming in.
so they must have like special shafts just to let the water through, huh?
Yeah,
And
there's
probably
bypasses. They're showing the intake down below. There's the turbine, and then the shaft goes up to the generator, and it flows back out.
Real interesting.
To generate hydroelectric, you need 2 points: an abundant supply of water and an elevation to draw it. Building a dam creates a dam creates a reservoir which stores water continuously while used. Water enters the generating system in a series of giant inflows, then travels down a steep pipe called a pinstripe, creating a massive pool of water with the base of the penstock, the water passes through a giant blades rotate the drive shaft of the turbine, which is connected to a large generator. This converts the mechanical energy into electricity. The electricity travels along high voltage wires to transformers, then onto transmission towers, where it connects into the provincial power grid. After passing through the turbine, the water continues through the tail race, where it rejoins the river below. Hydroelectric dams are a remarkably simple, sustainable, and clean way to generate huge amounts of power.
All right.
Where you want to go? So like you could, I see, I got there, we got there. We got there. We got the big one on the first one.
Project Fi from Google. The phone plan just got satisfying. Oddly satisfying.
I thought I saw something when I said dam first, but they're bypassing.
That's bypassing. Wow.
Yeah, they've got so much water above the dam. They're having to let it go without going through the turbines.
No, do they just pull the turbines up then? Or what? How do
No,
do
they
that?
have a separate passageway, like here.
Yeah.
So they've had rains. This is a spillway.
Was it earlier this year where California, the one up in California, that one just breached and remember that?
Yeah,
And that was pretty bad.
I don't know whatever came of that.
Well, I don't know. That'd be a good question. I wonder if they got an article or something.
I know they were letting the water out to get down low enough so it was no longer a danger. Clearly, it didn't cost or whatever about that.
I don't know. I remember hearing something about there's so much water that the surrounding area actually busted. And I don't know if it affected the integrity of the dam or not, but I
Well,
imagine it did.
That one dam that you're talking about, it was starting to leak through.
Did it break?
No, they were releasing as much water as they could to get the lake down. They were trying to release as much as they could to avoid causing trouble downstream. Because the towns below were going to get a greater flow of water. But they were getting the rains, so they would expect more water. But they were trying to drain it down to get below the damaged area.
So I suppose that's the biggest problem with these hydros. When you gotta release all that water, suddenly it's
Even
High
a small
pressure.
leak,
high pressure.
even a small leak will turn into a big leak because you get erosion. You get a
Yeah.
small, tiny pathway, and it carries a little bit of sand and dirt away, and it'll just progressively get bigger and bigger. It doesn't matter what it is, what the dam's made out of.
Yeah.